In lecture 19, we will mainly focus the initial value and final value theorem of Laplace transform, and we will also discuss one example later to this. Okay, initial value and final value theorem are very important topics. So normally we can expect some question from this particular area. Okay, now we will use initial value theorem. State that when you want to find out the initial value, that is limit t tending to 0, okay, or 0 plus of x of t, or we can, in a very simple way, we can say we need to find out x of 0, but we don't have x of t signal, but there is x of s. We know the transform of x of s, so it's very simple to calculate the initial value of a signal if you know the Laplace transform. Simply apply the limit s tending to infinity s into x of s. So that's the meaning of initial value theorem. So s tending to infinity, s into x of s equivalent to its initial value x of 0. So this is the time domain signal, and this is the Laplace transform of that particular signal x. And one more condition you need to remember: initial value theorem does not apply for a rational number whose numerator polynomial order is greater than the denominator polynomial. So always remember, if there is a question like this, it is not applicable for initial value theorem. Okay. Now we will discuss the final value theorem. So final value means we need to calculate limit t tending to infinity x of t. So we need to calculate simply the x of infinity. We need to calculate. In order to calculate that, we will apply and assume that there is no signal x of t, and we know the transform of that particular signal. So here it's very simple: s into x of s. Okay. This is the condition. Here also one restriction for that. In order to apply a final value theorem, all poles should be in the left half of the s-plane. Okay. So this is one condition to apply the final value theorem, and only a single pole at s is equal to 0. Okay. So these two conditions should be satisfied, then only we can apply final value theorem. Okay. If there is a pole at s is equal to, there should be only single pole. There will not be any multiple poles, and all other poles should be left half of this plane. Then only we can apply the. So it's very simple to remember. If you want to calculate initial value, the s limit should be infinity. If you want to calculate the final value, that's in x of infinity, you need to apply s is equal to 0. So just opposite. Now we will discuss one question. Determine the initial and final value of a signal x of t whose unilateral Laplace transform is given by one equation is given. Okay, transform equation. Now we'll apply the initial value theorem. Okay, initial value theorem states that x of 0 or 0 plus is equal to limit s tending to infinity. We need to calculate 0 or initial value. We will apply the limit s tending to infinity, s into x of s. Okay. So limit s tending to infinity, s into 7s plus 10 divided by s into s plus 2. So s cancel. Now we can take s common, so it becomes 7 plus 10 by s, then 1 plus 2 by s. So now we can apply the limit s tending to infinity. So when the limit is infinity, we will take like this. So if you apply infinity here, so this term becomes 0. So something divided by 0, infinity is 0. So we will get simply 7. So this is your initial value. Now final value theorem. So now we will apply the final value theorem to find x of infinity. In order to find x of infinity, limit s tending to 0, s into x of s. So in order to apply final value theorem, you need to verify two things: the number of poles at s is equal to 0. So there is only one pole at s is equal to 0, and another pole s is equal to minus 2. This is in the left half of the s plane. So no problem, we can apply this theorem. So s tending to 0, s into 7s plus 10, okay, divided by s plus 2 into s. So s cancel, so remaining we can apply s tending to 0 here, so we'll get 10 divided by 2, which is equal to 5. So we got the initial value and final value. Now I will tell you one more thing. So for this particular question, x of s, it's 7s plus 10 divided by s into s plus 2. So if you find the inverse of this particular system, you will get x of t will be like this, and it will directly write the result, 5 into u of t plus 2 into e raised to minus 2t into u of t. So actually x of s is the transform of the signal x of t. Okay, so we can find the answer up to this point, initial value and final theory. Now we can simply verify this particular result, only to verify or to make sure that we will get this particular answer in time domain also. So it's not needed in exam point of view. In exam point of view, you can conclude up to this point. This is only to verify this particular answer. So this is actually the inverse of this particular signal. Okay, and in order to calculate x of 0, substitute t is equal to 0. Okay, so you will get 5 plus 2, which is equal to 7. So we got 7 here. So x of 0 is 7. Okay, now now we can verify x of infinity. U of t is a signal, it will be like this. So when t is tending to infinity, the function magnitude is 1, same as, so we will get 5 itself at infinity also. So exponential signal, exponentially decaying signal whose value is tending to 0, e raised to minus 2t into u of t becomes 0 when t is tending to infinity. So this quantity becomes 0, so we will get 5. So this is also same in Laplace transform domain. This is in Laplace transform domain, and this is in time domain. Okay, so in exam point of view, you only need to do this part, okay, and this portion is only to verify your final answer.